Hi everyone, welcome to the channel. Today we'll be looking at this problem called search in rotated sorted array. And the problem is that we're given a sorted array in ascending order and it's rotated at some pivot unknown to us beforehand. So we see here the sorted array 0, 1, 2, 4, 5, 6, 7 in increasing order, and it becomes 4, 5, 6, 7, 0, 1, 2. So you see here that 0, instead of starting in this position, the 0th index, it starts at 0, 1, 2, 3, 4. It starts in the 4th position. And then whatever is remaining after you fill up the positions in the same size array, you continue from the beginning. So we see 4, 5, 6, 7 right here, continuing off of 0, 1, 2. And we're given a target value to search for. And if we find that value in the array, we return its index. Otherwise, we return -1. And a good thing to ask for clarification is whether or not duplicates exist in the array. In this problem, they tell us no, but it's good to ask the interviewer, see if we have to take that into account. And we see this example here that the target is 0, and we see it's 0 is right here, so it's in 0, 1, 2, 3, 4, 4th position, output 4. And we see target 3, and there's no 3 in here, so we're unable to find that. So we return -1. Now, when we see problems on algorithm data structures in interviews, it's good to ask clarifying questions. And one of those clarifying questions we should ask is, what do we do when we receive an empty array? And because I solved this problem before and I submit on LeetCode, so I know that when we have an empty array, we return -1. So that's one of the cases, empty array, return -1. Now, looking into the problem a little bit further, we can write out this example. It's good for when doing these problems to write out a long enough example. I'm just taking this example here. It's pretty generic, but writing out the example will help you find a pattern. And so we know that we have a sorted array, and we're also doing search. So binary search yields the best O of n log n runtime for searching in sorted array. Now, we know that the array is rotated on a pivot. So after that happens, it no longer is a sorted array. So binary search doesn't work. But we can investigate further and consider, can we do a modified binary search? Now, writing out this example, we see that the pivot is 0. And we notice that there are two numbers that are not sorted, and that's 7 and 0. So what we can conclude here is that there's always two numbers that are unsorted, and the two numbers are the pivot number plus the number left of the pivot number. And this fact is important because knowing that there's only two numbers that are unsorted, we couple that with the fact that in binary search, we always split the input into two, and then we check the left side and then we check the right side. And so now we have a couple of cases. Well, we check the left and the right side to see which side we need to search. So let's suppose that the left is sorted. Then we see if target exists in the left. And we search the left. Well, we can take one step back and also see that there are cases. So here are the main cases. We have one case where all elements are sorted. And that can happen if the pivot is chosen to be 0 and it pivots at the 0th position. Then everything is sorted and we perform normal binary search. The other case is if we don't have everything sorted, and we know that this happens when we have a pivot and it does not pivot on the 0th index. The pivot number does not pivot on the 0th index. And then, the pivot number is not the 0th element. And when that happens, we know that there's at most two numbers, well, always two numbers that are unsorted. And when that happens, we know that when you divide the input into two, we always have one side that is sorted and another side that's not. So to solve for this case, it's like what I was saying before, which is we check left side if it is sorted and target is within. Well, check left, checks to see if sides halves are sorted. If target is within those halves, search that side, else search unsorted side. And we know that in this case we will have one sorted and one unsorted. So if we search, we see that one side is sorted, and we see that the target is within that side, we will search that side. However, if one side is sorted and the target is not within that side, then there's no reason to search that side, so we would search the other side. And that's how we would proceed with our modified binary search. And yeah, let's code as we explained through the idea. Well, this is the main idea, so now let's proceed. And so the first thing was to take care of this edge case. So if not nums, so basically if num's empty, we return -1. Now we perform our binary search. And so binary search, we have our usual suspects, which is a low pointer, a high pointer. We'll take nums and subtract 1, and then we will do low less than high, meaning that when the two pointers cross, it means that the low pointer will have searched what the high pointer has searched and vice versa, meaning the binary search is complete. Now we're at the point where, well, the other usual suspect is a mid pointer. So we'll use int, that way we won't have float and then be unable to index, and then we'll add with low and divide by 2. Now we have our 3 pointers, and upon each iteration of our binary search, we want to check to see if the target is in the low pointer, low index, high index, or mid index. So we'll have 3 if statements to do this. Check to see if equal to target, and return the index, which is low. Same thing with high, and same thing with mid. Mid equals target. All right, so now that we have this, we check the case where the sides are sorted. So first we check the left side. Check if left side, well, contains target in interval. Then check similar concept for right side. So first we check the left, and we say, all right, nums of low less than equal to target. Well, we want the target between, so let's we want less than, not less than equal, because we already check nums of low. So there's no reason to check if nums of low equals target, since that's already an if statement prior. And then we check if it's less than nums of mid, which is the left side. So if it is, then we will move our high pointer. So if we search the left, it means that we decrement our high pointer to mid minus 1. And then we do the same thing for the right side. All right, so let's make sure that this is matching. So it's nums on top, so let's not do num. And low equals mid plus 1 to search for the right. All right, so now because we're using aleph, we know that once we're at this point on line 36, that target does not lie in low index, high index, or the mid index. And we also know that the left side is not sorted and containing the target. And also the right side is not sorted and containing the target. So now this means that what we seek for the solution is that target is possibly in the unsorted side. And we talked about before how that if we have one sorted side and one, if we have an unsorted side, then there's going to be one sorted side. So because of the two elif statements in 32 and 34, we know that the sorted sides do not contain the target. So now we must search for the unsorted side that does contain the target. And so first we check the left side to see if it's unsorted. And so the reason why we can't assume that the left side is sorted is that it's possible the left side is sorted and does not contain the target. Therefore, line 32 does not execute. So we check low. And if it's greater than mid, we know that it is unsorted. And so we would search the left in this case. So we do high equals mid minus 1. And then our other case is we must search the right because the right is unsorted. So we do mid plus 1 in that situation. Now, we arrive at a point where we return -1 because we execute our binary search and there's no, the target is not found. However, there's one edge case that we must be careful of, which is that the input can be one element. And we see that if the input is a one element, low will equal 0. Length of 1 is 1, 1 minus 1, also 0. So low equals high. Therefore, our modified binary search will not execute and will automatically return -1, which is problematic because let's say an example is 2 for our nums and our target equals 2. The answer should be 0 in this case, but our algorithm will return -1. So what we do is we must check to see if the low pointer contains the target. So we check low, we output low if nums of low equals the target, else we return -1. Now let's be careful and check through to make sure things are good. So we say check if nums not, if not nums, so if nums is empty, then we return -1. Next we have a low pointer and a high pointer, and length of nums -1. And then we do while low less than high, meaning that we have not finished with our binary search. We use int because we don't want to have floats. We can't index with floats. And then we check if nums of low equals target and return low. Same thing with high and mid, if we find it. And then we check if the left is sorted, so nums of low less than target, less than nums of mid. And then move the high pointer to mid minus 1 if we're searching the left. Move the low pointer if we want to search the right. Yes. And then we check to see if the left is unsorted. So that means nums of low greater than nums of mid. If so, then we would search the left, else we search the right. And yes, now handle the case where we only have one element. Else return -1. Let's check it out. All right, great. Looks like it works. let's talk about runtime for a little bit. So binary search, we know that it's O of n log n for runtime. And our modified binary search is just more elif statements than the typical one. And space, we don't use any space, so it's constant space complexity. Yeah, thank you guys for your time. I'd just like to let you know that for this problem, I posted um, explanations as well as code within my website. So if you want to have more resources to review rather than rewatching this video, please go there. And as usual, leave comments down below, anything you want to discuss. And also anyone in the audience that wants to chime in, feel free to do that as well. Yeah, thank you guys for your time. Please like and subscribe if you want more content. And yeah, I hope you guys had as much fun as I did, and I also hope you learned something and enjoy the rest of your day. Thanks so much. See you in the next one.